Hi, my name is Emily.
My name is Shipam, and we are grad student at the Farku Lab in the Plant Science Department at University of Maryland College Park.
In the Farku Lab, we investigate how to develop novel strategies for improving fruit quality, nutritional value, shelf life capacity, safety, and marketability.
In this video, we will demonstrate how to assess apple fruit maturity using different maturity indices that are useful to determine optimal harvest time.
We'll start with color changes. Changes in the surface color, or the part of the skin colored red, and the background color, the part of the skin colored yellow or green, are important maturity indices. Generally, for the surface color of red-colored cultivars, the indicator for its commercial grade will be based on the percentage of the surface of the fruit that has a good shade of red color. The more color, the better the grade. For example, in the case of Honeycrisp, the acceptable minimum color for the retail sector is 50 to 60% red coloration with no hard green. For measuring changes in background color, we use a difference of absorbance meter or DA meter. Here, Shipon is performing the calibration. The DA meter is a device that measures the index of absorbance difference, or IAD, which relates to the actual content of chlorophyll A in the skin during fruit ripening. The DA meter is a handheld device that shines LED light into the apple, and a sensor measures how much light reflects back. Values of IAD will decrease as the fruit ripens and chlorophyll degrades. For each apple cultivar, a characteristic DA index can be developed. DA index readings of 0.6 to 0.7 are recommended for long-term storage, while 0.35 index values are recommended for short-term storage. Another important index corresponds to fruit firmness changes. As fruit matures and ripens, the flesh becomes softer. As flesh firmness highly correlates with post-harvest storage quality, firmness is a key aspect to measure for long-term storage. Fruit firmness, or pressure testers such as penetrometers, have been developed to measure these changes. These instruments determine the amount of pressure required to puncture the flesh of the fruit without the skin. For testing, remove a disc of skin between the size of a nickel and a quarter on both the blush and the non-blush side of the apple. Against a hard surface, force the tip of the plunger into the fruit of the exposed flesh. It should take 2 seconds to push the plunger in at a consistent speed. Applying pressure too fast can result in an inaccurate reading. Measure both sides and average the readings to determine the value. In general, apples that are destined for long-term storage should be harvested with a firmness of at least 15 pounds, while fruit for shorter-term storage should be harvested with 13 to 15 pounds. Starch content changes are another important maturity index in apples. Starch in the fruit flesh is converted to sugars as apples mature and ripen. The maturity stage of apples can be determined by performing a simple starch iodine test, which records the degree of starch disappearance in the flesh. As iodine binds to the starch molecules in the apple flesh, a blue-black coloration develops. Cells that contain sugars will have no color change. Iodine solution can be purchased ready to use and is kept in a well-labeled opaque container or wrapped with aluminum foil, as it will fade if exposed to light. Gloves should always be worn to avoid skin contact, and tested apples should not be used as compost or for animal feed, as it is highly poisonous. To perform the starch iodine test, cut an apple in half horizontally and place the apple, cut side down, in the solution. After 1 minute, remove them, drain off excess solution, and set the treated side up for 2 minutes. The pattern for starch disappearance is specific to each apple cultivar. The common starch index rating system is on a scale of 1 to 8, where 1 is full starch or all black blue, and 8 is starch-free, no stain. However, not all apples are scored according to this scale. For example, there is a different standard starch chart for Honeycrisp, ranging from 1 to 6. The stained halves are compared to the chart to determine the stage. Although it varies by cultivar, values ranging from 3 to 5 on the 1 to 8 scale are generally recommended for harvesting apples for long-term storage, while 6 to 7 is recommended for a fresh market. The last index in this video corresponds to the sugar contents of apples, which increase as the fruit matures and ripens. A manual, or digital refractometer, is used to measure the sugar contents or percentage of soluble solids of an extracted fruit juice sample. Fruit juice as a byproduct of the firmness testing or fresh pressed juice can be used. Measurements are performed by squeezing a small amount of juice into the device's prism. After each juice sample, the prism surface should be rinsed with distilled water and carefully wiped with a soft tissue to prevent contamination between samples. It is recommended to harvest apples with readings of around 12 to 14% SSC, but the ideal reading will vary by cultivar and selected market for the fruits. Determination of apple harvest maturity and optimal harvest dates can be achieved using different maturity indices. A good strategy is to take into account several indices when making harvest and storage decisions, especially as weather conditions become increasingly unpredictable with climate change. This is important as an individual maturity index cannot explain the true maturity status of an apple. As each cultivar and even orchard block will vary on their maturity indices, it's important to collect a fully representative sample of apples to conduct these maturity tests. Fruits should be monitored weekly starting around 4 to 5 weeks before the anticipated harvest date. Thank you for watching and happy harvesting!